So hello bachcho, welcome once again. See, today what we are going to discuss a very important concept of series which we will be using in binomial. It's a general concept related to series where we have to solve the double summation. So I will discuss few aspects of such type of question. Okay, so let's start and see. Be very alert while you are listening or watching this video. It might be really very helpful in the days to come. Okay, so see, the question is you have to evaluate this double summation of 1. Mind it here that 1 is a constant independent of both the variables of this summation, that is I and j. So these are the two variables where the condition is I is greater than equal to 0, less than equal to j, which is less than equal to n. That's what we have to evaluate. Okay, now see how to approach it. So for that, see, I will say that if I have to evaluate it without any condition on, like relative condition on I and j, if I say that I and j can take any value independently, then what does that mean? That means the two summations are independent of each other. So in that case, see, we can solve it separately. What does that mean? That means I can evaluate this. So I can write j goes from 0 to n. And what is summation of 1? Summation of 1 gives us the value which the variable takes. Like I here, I is the variable of the summation. How many values does I take here? I goes from 0 to n, it takes n plus 1 values. Okay, so when you are writing summation of 1, what does that mean? For whatever value of I you put, the value will be 1. So 1 plus 1 plus 1 plus 1, how many times? Number of times the value I take. So I is taking n plus 1 value, so the summation is n plus 1. Now since again n plus 1 is a constant with respect to j, you will take it out here. So you took out n plus 1 and you got summation of j which goes from 0 to n of 1 again, and again it is what? It is nothing but n plus 1. So n plus 1 into n plus 1 is n plus 1 whole square. See, so that's the method we can follow or you can use whenever there is no relative relation or there is no relation between these two variables of the double summation. But since that's not the case, so what are we going to do here? Because here it is informed or it is told that I is less than or equal to j. So that there is a relation between I and j. So for that case, see, what I will suggest you, what I actually want to discuss here is matrix method. Now what is matrix method? See, in matrix method, what do we say? We say that row and column, of course, matrix is a rectangular arrangement. Okay, so I will say rows, along the horizontal row I will be mentioning the value which I take, and along the column the value which j takes. So, okay, I take 0, 1, 2, 3, 4 till n. J takes the value 0, 1, 2, 3, 4 till n. Okay, now see, how do you use it? So if I try to complete this matrix, just a minute. So we just put the value here, bachcho, for I and j. Okay, so I'm just, wait for a minute, I'm just trying to complete it quickly. Right, so that's the matrix, let's say. Okay, this is the position for when I is 0, j is 0, value is 1. Why? Because see, summation of 1 is required. Now 1 is independent of both I and j. So whatever value you provide to I or j or both, the value of the function of summation is 1 always. So that's one case, so it's independent of it. So that means I can write, of course, this is the position when I is 1, j is 0, I is 2, j is 0, I is 3, j is 0, I is 4, j is 0. For every value it's 1. Now that's the position when I is 0, j is 1. Okay, I is 1, j is 1, I is 2, j is 1, and so on and so on. So in this particular case, at least you have 1 everywhere and everywhere and everywhere. Okay, at every position you have just 1 here, bachcho. So this is 1, 1, 1, 1 and 1. Now if I am looking for this double summation, which double summation? If I am looking for this double summation, okay, so what am I looking for? How many times I am writing one to complete the matrix? Okay, so when I goes take the value from 0 to n, j takes the value from 0 to n, how many times am I writing one? See, in a row there are n plus 1 times 1, and how many rows we have? N plus 1 rows. So therefore, see, so summation of 1 when I goes from 0 to n, j goes from 0 to n is nothing but n plus 1 whole square. Am I clear? See, that's why I just quickly solved this separately. Okay, so that you can match it with this one. So how many times you have 1? You have n plus 1 square times 1. Okay, so the double summation of 1 when I goes from 0 to n, j goes from 0 to n is n plus 1 whole square. Okay, now let's come to the question. So the question is, for us, the question is, so double summation of 1 when I is less than equal to j, it's j here, less than equal to n, which is less than equal to 0 on the other side. Okay, so now look at this matrix. Now if you of course it's a square matrix. If I move along the diagonal, something like this, if I move along the diagonal, the position is, this is 0 0, I is equal to j, this is 1 1 position, I is equal to j, 2 2, 3 3, 4 4. What does that mean? That means on either side of diagonal, one will be greater than the other. I is greater than j on one side of diagonal, and I will be less than j on the other side of diagonal. Okay, let's see. So if I am looking down below the diagonal elements, so what is the position? So if I look at it, I is 0, j is 2, so I is less than j. So when I is less than j, okay, then we are looking for the elements which are below the diagonal. Total number of elements in matrix, how many are they? In matrix are n plus 1 whole square. Total number of elements along diagonal. So it's a square matrix, so in diagonal also you will have as many elements as the elements in a row or in a column. In 2 cross 2 matrix, number of elements in diagonal along diagonal is 2, are 2. 3 cross 3 matrix, number of elements along diagonal are 3. So in n1 plus 1 cross n plus 1 matrix, number of elements along diagonal will be n plus 1. So therefore number of elements below diagonal, how many will they be? Is equal to number of elements above diagonal, isn't that? It's a square matrix, bachcho. And how many will they be? So they will be equal to n plus 1 whole square. Remove the diagonal elements from all elements and divide by 2. Now just simplify it. So you take n plus 1 common, it is n plus 1 minus 1 by 2. So it's n plus 1 into n by 2. These are the number of elements which you have below diagonal, and we need, see, when I am asked, and one more thing, okay, so when I ask you to evaluate this series, so it include I is equal to j also, it include I is equal to j. I is equal to j means diagonal elements, and since all elements are 1, so number of elements gives us the answer, isn't that? Because how many times are we writing 1 here? So if you are writing 1 10 times, so if you add them you get 10. Okay, so number of elements below diagonal or above diagonal are these many. Number of elements along the diagonal we already know is these many, so just add them. We need to just add them. So therefore the double summation of 1 when I goes from 0 and j is less than equal to n is nothing but n into n plus 1 by 2 plus n plus 1 बच्चों. take n plus 1 common, it will be n plus 2 by 2. That's one approach. That's the approach we use using matrix method. Okay, I believe you people would have understood. But now let me discuss one more approach, but that approach, see, matrix method you can use in other cases also. But the one thing which I am going to discuss here, that will work only for one, like double summation or triple summation of 1. What is it? See, I goes from 0 to n. How many choice we have for I? For variable I, we have n plus 1 choices of numbers, isn't that? For variable j, we have n plus 1 choices of numbers. Bachcho, fine. Now, if when I is less than j, when I is less than j, okay, so that means out of n plus 1 you select any two. By these are two variable I and j, so you can assign in how many ways you can assign or take two numbers such as I is less than j, where I is between 0 to n plus 1, j is between 0 to n plus 1, so there are n plus 1, so you see two ways. N plus 1, see two ways when you pick two numbers between 0 to n plus 1, and one will of course be less than the other one. Okay, and the second possibility is I is equal to j. I is equal to j. So I is equal to j, you have to pick only one number out of n plus 1. So n plus 1 c1. Now this is either or condition, either I is less than j or equal to j. So that means we need to add them. So total number of ways in which we can select the numbers such that when one is less than other or one is equal to other, so you add them. So it's n plus 1 c2 plus n plus 1 c1. Now from the property of binomial coefficient, we know that this will be nothing but n plus 2 c2. Now look at this, they are same. But this method, see, both have their own pros and cons. This method may work for other type, except for, besides for one, it may work for other numbers also, not number, maybe for expression also. We will take up those questions also in the days to come. Okay, but this will work, though it works only for one, the constant number 1, 2, 3, anything is there, it works for one. But it may work for triple summation, fourth double summation, triple summation, quadruple summation, and so on and so on. Okay, so that's it. So that was the question. Now see, we have another one in the same line, and that is, now you know this answer, bachcho. Okay, and that is double summation of 1 when I is greater than equal to 0 but less than j. Okay, so that's the answer. See, if we go with this one, the answer is direct. The answer should be n plus 1 c2. Got it? Because here what we need is I is less than j. So in how many ways you can select two numbers out of n plus 1? It's n plus 1 c2. So it should be n plus 1 into n by 2. And if we go with matrix method, bachcho, when I is less than j, so that means you are looking for all those ones which are below diagonal. So how many elements we have below diagonal? So number of elements above diagonal or below diagonal were n plus 1 into n by 2, which is nothing but n plus 1 c2. So that matches again, bachcho, matrix method and the number of ways of selection method. So these two methods, you can use any one of these two methods to solve such double summation, bachcho. Okay.